So here's typecasting. Typecasting is effectively taking a data type and believing that it is a different but similar data type.
Yes.
So for example, if we have a integer value and we typecast it as a float value, although we're still storing the actual integer value, we're now going to interact with it as if it was a float value. And so that's typecasting. So when you deal with variables, you are going to be dealing with a lot of different types of variables, and you won't always be able to stick with the same data type. You might have to move from data type to data type.
Now, there's also a different form of conversion that's way more advanced than typecasting, which we're not going to even get into in the introduction videos. When we get into programming videos, we'll visit that topic then. So let's kind of look at an example of where typecasting is actually used. So this is a practical typecast example, Brian. So we have integer x equals 4, integer y equals 10. Now I want to have a double value, which, as you guys remember, is what is it, 32, a double-sized floating point value. So we have z equals y over x. So this is 10 divided by 4. Why does z equal 2, Brian? They don't divide into each other equally. There should be a decimal place here.
But the division operation is being applied to two integer values.
Really?
And then the integer value, as a result of the division operation, is being stored as the double.
Well, how do I correct this then?
Well, by typecasting the two integer values, obviously. So now in this case, which is different than having the integer divided by an integer and then the result be a solid number, which was 2, stored as a double value, 2.0 effectively. In this case, we're typecasting the integer value y and the integer value x as doubles. So now we have a floating point precision on the y and the x. So when the y is divided by the x, we have a precision with which to store the remainder. So the 10 divided by 4 gets resulted as 2.500 whatever, however much space we have. That result then gets stored as z, so z can maintain that precision of 2.5.
And one thing that's kind of interesting to note here is when we typecast these values, we're temporarily using them as doubles.
Right.
So we're saying take y and just pretend it's a double.
Right.
So we're not actually storing y as a double. We're saying in this instance, at this specific moment, pretend it's a double.
So effectively, after we've stored z to be 2.5, y is still an integer.
Yep, still an integer, sitting there collecting no decimal points.